Still move a bit further right if you can. Oh, I see there.
Yeah. Height is good for you?
Yeah.
Hello, everyone. Welcome to the BPF BOF. We're all glad you could make it, and thanks for the people being remote as well. Let's get started. I think people are still settling in the back, but we'll try to get started right away. So I think you need the slide control, Lorenzo, right? Like so. You need to move to that window. This window. Yeah. Move. Yeah. Yeah, so maybe this early on Monday still, so please look at the note 12. So there's like some kind of rights you give to the IETF for the contributions and what the contributions are. They are defined in great detail, and please look at the RFCs that are and the BCPs that are referenced for like more information. Next slide. And for this meeting, we appreciate if you can get on the on-site tool if you're in the room, so we can queue the things in a unified manner, so we can manage the remote queue and the local queue together. It's going to be difficult for us to track who's in line without that. And if you're not actively speaking at the mic, please wear a mask. And that's pretty much it. Like on the logistics side. Next slide. Yeah, keep going. Okay, so just to go quickly through the agenda. So we have like few blocks of presentation. So we just like start off with the chair presentation, like, some like logistics stuff to get out of the way. And then we start with an overview. Alexi is going to start us off, like showing us like an overview of eBPF for people who are not familiar with the technology. And we go through a bunch of implementations on different platforms to just show like, what is like actually in the market right now. And we go to the position from the eBPF Foundation, and then we kind of go to the BOF formation questions, if possible, after that. So there's like one specific thing I kind of want to get out of the way. Like I'll just, when like Lorenzo gets the slides back on. Okay, so this is something we kind of had like a bit of discussion about, like, and Joel, thanks for bringing it up. I saw Joel in the room. And so this is something we kind of wanted to raise early with the leadership of the IETF, so kind of not to like worry about it later. And we had the chairs, the proponents, and the IESG had a meeting this morning to talk to the IETF legal counsel. And overall, the disposition seemed to be pretty positive. So I actually put in the text in blue, where the IETF legal counsel thinks that there is like the licenses that are available for this RST files are compatible with the contributor rights that the IETF needs, but it still needs to get worked out. And we kind of don't want to focus on the legal stuff in this meeting, so we're kind of ruling that out of scope, right? Like, but this is certainly something we need to discuss before a working group is formed at some point, if we decide to form a working group. So we're not like shunting this, we're just like waiting for more clear instructions from the legal counsel. So overall, the initial disposition is positive, but we're still waiting for more concrete input on how to actually handle this. And Lars, if you want to add anything there, that'll be perfect.
Yeah, hi, Lars Eggert, IETF chair. That's all correct, right? So in other words, normally when we do a BOF, right, we look at the technical work and the usual scope questions, right? Here, there's a separate track where we also need to analyze the licensing stuff a little bit more. So there's like 2 green lights that need to go on rather than usually just the one. But we expect there will be 2 green lights. Well, we expect there will be 1 green light on the licensing side, per the discussion this morning. Whether there will be 2 green lights depends on this room later.
Thank you. Thanks, Lars. Kono-san, did you want to say something or? Okay. Okay. So, without much further ado, I think like we just need to go. Okay, that's good. So, any questions on like the basic logistics or on the agenda itself, like how we go about it? So think of this as agenda bashing. And we greatly appreciate it if anybody can take notes, but like worst case, we can always go back to the recordings, but like there's like a Etherpad we can use to take notes, and greatly appreciate anybody who can put something in. Okay, thank you. Okay. So on the overview and implementation, so this is the order we're going to follow. So like Alexei is going to start with the overview of the eBPF itself and talk about the Linux implementation. Then we go to Dave, who's going to talk about like, a bunch of implementation, the status on them, and also specifically about the eBPF on Windows. Then we go down to Christoph, who's going to talk about the NVMe related implementation, and then go to my awesome co-chair, Lorenzo, who's going to talk about the Android implementation of this as well. So much further ado, like Alexei, if you can.
Stuff or no? That's later.
Yeah.
Okay. Okay. Okay.
So switch to
Yeah.
Alexei's slides.
Yep. And over here.
For those who didn't know, Alexei is, I guess I can call you the inventor of eBPF, if that would be correct. Yes? Take it away.
So Alexei, follow the next slide when we can.
Yep.
So hello everyone. My name is Alexei Starovoytov. I'm one of the co-inventors of BPF along with Daniel Borman. Also sitting here and over here.
Closer to the mic, and you can raise it.
Turn it on, it's probably going to be better. Good. Excellent.
Okay. Oh, wow. Nice. I can hear myself now. Good. Working well. All right. So let's just talk what BPF stands for. Show me your hands, like who heard the BPF abbreviation before? All right, so well, then I can skip this slide. So the only interesting part on it is that there was a bit of a confusion what BPF and what eBPF is. So right now we define it as BPF is like the whole ecosystem, where eBPF stands for extended BPF, in particular to only instruction set part of it. The interesting like side note of it is that initially back in 2013, when it became part of the kernel, the whole instruction set was called internal BPF because we didn't expect at this point that it will be exposed to user space and it will become famous as it is now. So it should have stayed kernel internal, but well, fast forward 10 years and now it's part of the Windows 2. Next slide, please. So in one sentence, like some people describe BPF as a virtual machine. My new definition as of this night is BPF is a universal assembly language. You can think of it as an assembler that is strictly typed, meaning that in the normal, for example, like C style or C++ linker, like C++ does it with mangling, but in C, you want to like link with the function foo, like linker will allow you. In BPF, like the types has to match. So C++ kind of goes with the mangling of the name. Here, we actually do it in the full type comparison. It's safe for it to execute in the kernel or in the hardware because we have what we call a verifier that analyzes the instruction and understands what these instructions are doing. In the normal CPU, take x86 ARM, the CPU in a sense is dumb. that it interprets like if it is a register, like 64-bit register, 64-bit means it's 64 bits, nothing else. From CPU point of view, they are bits. In BPF, they're never like bits. It's always, there is some meaning to the value that's in every register. It can be pointer, and pointer to the packet is different pointer from some like kernel data structure. Pointer to a map value is also different from like pointer to like something else, scalar values and so on and so forth. And the last part, it's often like people ask, what's the stability and backwards compatibility story for BPF and whether it's stable or unstable. In Linux, there is a concept of called UAPI, user space APIs, and a BPF instruction set is bound by these rules, meaning that we do everything is possible to make sure that instruction set is stable, and we only do backward compatible changes, extensions. Next slide. Quickly about design goals, I already touched that the key concept of the instruction set, that it's verifiable, meaning that it's understandable by, it's sort of like a language. When you speak this language, your opponent understands it, so you understand and you're being understood. So this is absolutely critical, and that's what differentiates this instruction set from like x86, Spark, and everything else. Two other aspects, some people ask again, like why BPF is so fast, how it compares, some other people actually saying, well, is it really possible for this instruction set to be compared to be just as fast as a native? And it was done because this is how it was designed. So there are two aspects of it, why it's fast. First, it's instruction set itself that made it such that translation from compilation from the C code into this, let's call it intermediate BPF representation, and into finally native instruction set, is the instruction set was picked in a way, designed in a way that is this last step is pretty much knob. So all of the optimization that compiler does, they benefit the final translation too. So that's one. And the second part is the calling convention, the PSABI of the BPF ISA was selected such that it's zero overhead to transition from native calling convention into BPF calling convention and back into native. So these two like unique aspects of it. Next. You may look now at this history of the 9 years and see that some of the funky stuff are really look dumb right now. For example, when it was introduced, there were no less operation. It could only compare greater or greater than equal. And it was done because we tried to make it look to kernel maintainers that it's similar to this classic BPF. And a classic BPF in the left bottom, you see it has two labels, unlike normal CPU instructions. Like if you match something, you jump to there or you fall through. In a classic, you either jump through or jump false. And because of it, like classic BPF could get away with having only greater operation, but then extended obviously on any other like normal CPU, like without less operation, compiler needs to do some like crazy work. So that was the first extension that was added, adding less operations about like year or so after initial instructions had landed. There are other like interesting quirks, like there is no byte swap operation in the instruction set. There is only like host to network, H2N, H2NL. Back then it looked like, well, interesting feature because instruction set was targeting networking, and the networking, why did you swap bytes? You only really care whether it's network order or not. So another omission. And inside the division was another, like, why would anyone bother with signed? Next slide. So this is how we extended BPF over the last 9 years. Total, there were like 5. The major additions were, as I said, less operation, then 32-bit comparison, and of course atomics. Initially, there were no atomic operation other than atomic increment. Now we have pretty much everything you find in the normal CPUs. Compare and swap, exchange, sync, fetch, and add, and so on and so forth. Currently, we're working on the next set of instructions that we call an MCPU v4. This is work in progress. It will contain signed sign extending loads. Finally, we'll have a byte swap and so on. So the interesting part here is sign division. So there is no actual, well, as far as I know, no actual use case for the sign division that people ask. So we're adding it mainly to consolidate XBPF. You can think of XBPF as a fork of eBPF that GCC folks added. So they were not really like trying to fork there. They were thinking about it as, well, there is a GCC test suite and they want to compile 100% of the self-test. And there is a signet division there, so it looks like a mission. Let's add this instruction. And since it's not eBPF, they just like went ahead, resolved like some bits in opcoding and said, well, this would mean like sign division. And just to make it different, they were calling it XBPF. So now we're working with GC community, LDN community, kernel community in terms of, and hopefully, well, the reason why I come in here was the whole IETF community in terms of how this like new instructions will be defined. Next, please. Example of typical workflow of with BPF programs. There is always typically, most of the time, there is a user space application that driving loading of the programs into the kernel. In the Linux kernel, they're done with a BPF system call. In Windows, I'm not even sure. They will talk about it. It goes through the verifier and JIT, whether it's Linux or Windows. And at the end, it's get attached to different interfaces. Like here, you see on the left bottom side, 2 red blocks that says like BPF code. The one on the bottom, what we call XDP, Express Data Pass, is the fastest way to process the networking packet in the Linux kernel. Speed-wise, it's the same as kernel bypass technologies, like many exist, where the whole driver is implemented in user space and the packets get delivered in the user space memory, and then user space does whatever it wants with it. But without kernel in the loop, the resource control of the networking device, of course, is challenging. And here, the programs run in the kernel right in the driver and achieves the line rate. Next slide. This is the example of production application. It's called Catron. It's used by Facebook, Dropbox, and I believe somebody else. Use pretty much any traffic. You go to the Facebook, look at the cat pictures. Before you see it, it goes through at least 2 layers of this Catron load balancer, first at the edge and then later in the data center. And this is how this BPF program looks like for real when it's processing these cat pictures. Next. So why we went from IPVS that we used in Meta initially and developed this technology XDP. Well, we call it XDP because why not? Like BPF is a 3-letter abbreviation, XDP also one. Must be fun to invent. So, and this is a performance difference. So the greenish graph is XDP performance in terms of number of millions packet per second. And you see the jump from a factor like 6 million to like 30 million. And this is on the denial of service attack. So for the big data center, we experience massive distributed denial of service attacks more or less all the time. So, and this technology allows to absorb it with much less, well, easier, let's put it this way. Next slide. In the Linux kernel, BPF can be attached to all of these different components inside the kernel. In the networking specific hooks is XDP and TC. Then there are like various socket related, flow related. Then container like cgroup is everything, like any cgroup effectively is one container. So it's we can override byte connect that is used by like Kubernetes and Cilium. Socket creation to, let's say, denying like particular sockets. Tracing, the whole part, like this presentation mainly talking about networking, but tracing is a huge giant area where BPF is also shining. All kind of observability and monitoring in the fleet is done through this tracing hook, which is kprobe, uprobe, system call, performance events, trace points, and so on and so forth. The interesting part that marked as green, this TCP BPF, is what we use today to experiment with various congestion control algorithms for TCP. We were not satisfied with what DC-TCP, BBR, etc., Cubic provide. So currently, various congestion control experiments are being in progress, and BPF allows us to deploy it and test at scale. Next. Besides the congestion control that I already mentioned and the load balancer Catran, another XDP program that also processing all of the packets, every single packet that goes in and out of the data center is a firewall. You can imagine how it would look, just like filtering based on IP, port, and combination. Some people think that since BPF is so level in the driver, it cannot operate at a higher level of the stack. So it actually can just as fine. So it works well for the layer 7 proxy and various analytics like analyzing TCP stacks or analyzing bottlenecks in networking. For example, like networking monitoring of various kinds, it's also done with BPF. At the end, if you look at any given, like just pick a random server inside the metadata center, it will have about 100 different programs loaded at any given time. Next. We've seen first smart NIC that runs BPF in the hardware, and that was Netronome. The interesting part here that BPF instruction set itself is 64-bit, while Netronome hardware has only 32-bit registers. So for them, initially to simulate 64-bit registers, just like doing +1 in 64-bit, they had to reserve the pair of 32-bit physical registers and do some like extra stuff. That was obviously inefficient, and working for over a year, we've added few like extensions to the instruction set, to the verifier, to the LVM. So it was a combined work between different companies. In this particular case, like Netronome, at the end, the hardware benefited a lot because the verifier, so as I said in the beginning, the instruction set is not just, it can be understood, it can be analyzed. So verification is a part of it, but analysis is a key here. After verification, the verifier could tell that none of the instructions are using upper 32-bit of this register. Since they are not used, the hardware is free not to allocate this pair of registers, but just use half of the registers possible. And at the end, the whole program, well, instructions, the specific NFP instructions that run in the hardware, that's half the size, 2x the speed, and all the goodness that comes with it. So that's the power of the instruction set being verifiable or analyzable. Next. As I said in the beginning, it's strongly typed assembly, and the typeness comes from BTF. We cannot pick original names. We should have called Smart Shark or something, but we picked BPF type format. It's pretty much like Dwarf, but used not only for debugging. It actually described the types that used by this assembly language, and kernel and the hardware actually enforcing this type. So when we're talking about standardization, we will be talking about different aspects of this whole BPF ecosystem. The instruction set is one aspect of it that is most accurately defined right now. This BTF type format is another, and we already have a list about 10 different other things that we are planning to work with you to standardize. Next. And these are the things. So instruction set most likely will go as number one. So this is like what we're thinking today. What would be the charter for the working group, assuming success in its creation? Instruction set probably will be the first. Definition of the valid program, maybe second, because it's for normal CPU, of course, like any program that executes on a CPU is kind of the valid one by definition if it's not using undefined instruction, it will run. Like CPU would have to do something with it. For BPF, we're not gonna just say just throw stuff into it. The program has to be valid. So definition of this validity is can be anything, and it ties into what like verifier can do. Whether the valid program means that every address needs to be understood, whether it's an address, whether it's a pointer to a packet memory, again, like pointer to a map, or like allocated objects of the kind. This is all of the aspects that we are going to like argue about. BTF, this type format, then there is extensions to this BTF type format that go beyond type, where we do what we call compile run everywhere, somewhat similar to Java, some ideas like borrowed from Java, where the same program can adjust itself dynamically to the underlying kernel. And it allows to program in C as instead of fixed offsets, we can do symbolic programming. When you dereference a field, you don't dereference field at a particular offset, you dereference it by name. And the ecosystem allows to do that. PSABI, which include calling convention, linker requirements, and so on and so forth. And of course, at the end, the architecture part to define what we think should be like maybe the bare minimum required set of program types like XZP that are already supported by Windows and Linux, and what else should be on that list. That's all I wanted to say. What questions do you have?
Thank you. We have a couple of minutes for questions if you want, but if you want to discuss stuff about like the whole content, like we have some room reserved later. So hold off on your questions unless you have something clarifying.
Thank you.
Thanks. Thanks, Alexei. Dave?
All right, I'm Dave Thaler. I'll be talking about eBPF on Windows, and at the beginning, other things in general. Go ahead, next slide. So for any of the components that we talk about in BPF, whether we're talking about the JIT compiler, the verifier, compiler, whatever it is, right, there exists already multiple independent implementations of every piece. And that's one of the justifications why all the things that Alexei showed could be standardized if they could all agree on doing it the same way, right? The things at the top, people tend to agree on doing it the same way. The ones at the bottom require more work to get that agreement. This is just showing a number of projects down the left and a bunch of different platforms across the top, and sort of what year that work or support was either, started or declared or finished or whatever, various major announcements. And so there's a bunch of projects involved. And so I'm going to focus in the rest of this on the eBPF for Windows. But the point is there's support for lots of different platforms that all use different implementations. It's not just the Linux kernel implementation. That's just kind of the first dominant one, but it's not the only one. Okay, next slide. And so going across that, there's a couple of observations. You see BPF is already supported on top of multiple operating systems. It's supported, or at least there are projects doing it for both eBPF programs that run in the kernel as well as one that run in user space, say to extend a system daemon, for example. Whether it's running on the main processor or on something like a SmartNIC, like in the Metronome case that Alexei mentioned. People use it inside guest VM as well as on a host, inside or outside containers, native code or interpreted, but interpreted is usually seen as being a security vulnerability, so we're trying to kill that part. But the point is, there's lots of different heterogeneity here, but they all use the same tool chains and APIs, or at least that's the goal, right, is to get the convergence there. Many of them already use the common set, and the goal of standardization is to converge those even more. Okay, next. Okay, so this is the this is for the spot the differences, right? This is the equivalent of the slide that Alexei showed. And so keep track of where on the top left you have compilers, which include like Clang and GCC are two examples. You have libraries for applications to use to communicate with programs like libBPF and GoBPF and so on. You have a verifier component, you have a JIT compiler component, and you have the native JIT compiled code that interacts with something like a TCP/IP stack if it's networking, or storage stack if it's storage, and so on. Okay. So go forward a slide. Now you'll see spot the differences and the Windows implementation. If you ignore the color coding here, what you see is the verifier and the JIT compiler are running up in user mode in a privileged system context, as opposed to in the kernel, but they're still just as privileged as the kernel there. And so it's the same flow. You see on the left, it's exactly the same Clang in GCC. It's not a Windows one. It's just a regular Clang in GCC that generates the same type of L file. You have a Windows library that supports the same APIs. The bytecode then gets JIT compiled and put into the kernel there where it interacts with the TCP/IP stack in the networking example. So the color coding here is that the choice that we're making in Windows is this is not in Windows. This is on Windows, or eBPF for Windows, which is what you see in the title there. And that's because we don't want to say, hey, you just got to wait till the next version of Windows before you can try this. It's like, no, people want to use it now. So we said, okay, if you got, Windows 10, you got, Server 2019, you can already do it, right? We're working on getting it signed because right now you can only do it in the, if you put your machine in test signing or developer mode, then it will work. We're trying to get it signed. So the point is, this stuff here is actually undocked. All the stuff in the eBPF for Windows project is open source. So if you say, is something supported? We can say contributions gratefully accepted. Next slide. Okay, so yeah, I'm in the operating systems group at Microsoft. We do both Linux and Windows, right? So half of my peers are like Linux systems group and the Mariner distro, and half of my peers is like Windows networking and Windows storage and so on. And so there's people that want to write cross-platform code that's in the group. Do we want them to write it twice? No, we want them to write it once, right? If you want to write a load balancer or an add or something, do it the same way. Try to get rid of two different implementations if you can do it the same way. And so to do that, we said, well, Linux already has we're already using the BPF support there. Why can't we fill the gap on Windows so that you can do the same thing there? And so that's where this project started about, 2019, I think we started. Okay, so the things that we're using in the eBPF for Windows project, we're using the L file format. Right now, the one that's supported is pre-BPF, which is matches sort of an older Linux kernel before the BTF stuff was added into the L format. It's using the preval verifier, a number of program types, all the program types and things I listed are the cross-platform ones, right? You could do OS-specific ones, but everything listed here is stuff that's the intent is source code compatibility with Linux. If you've already got something that you've gotten written, it's the same code. And so you see a couple of program types or hooks, or if you want, map types, meaning shared memory types, a bunch of them there. Helpers or functions exposed by the platform. And it's got the standard ones for maps and tail calls and various things you see up there. What's also interesting is that there's a separate project that's the BPF conformance suite, also done by a different guy at Microsoft, that said he took the Linux kernel self-tests and augmented them with some other test cases, wrote a conformance test suite against the ISA document, and now exactly the same tests run against the Linux kernel as it runs against the eBPF for Windows project, and I think one other project too, like UBPF. It's exactly the same test that runs. So we can say, yes, they all adhere to the same document, and if we rev the document, the tests get updated. And so he's done a great job of having a test suite for the document that is the first bullet on that list. It doesn't have all the test cases yet, so like atomic support were added, and that's not in the conformance test yet, so that's test suite yet. And then the last one is just an anecdote. One of the use cases that we've used in demos is in the Cilium project. There's a layer 4 load balancer that was designed to run on Linux. And we said, can you port that? Because the goal was source code compatibility. Can we get that to run on Windows without modifying the code? And the current result is 95% of it runs unmodified. We had to change 5%. What do we have to change? Number one, it called in a couple of APIs we haven't exposed helper functions for. That was for diagnostics, right? So we IFDF those out, okay? That'll show up eventually, right? But it's not the core load balancer functionality. The other part was there was some assembly code in the Cilium code that instead of writing it in C, it was writing it directly in the bytecode and assuming it could match there. And it turned out that the assembly code matching with a C that didn't pass the preval verifier. All we did is we took the assembly code, put back in the original C code that was in Cilium, and that passed it just fine. And so it's running the original Cilium code as opposed to the assembly little part. So that's the other part of that 5%. Okay. So the point is 95% and increasing, greater than, right? The later that you check, the higher the number will be. The goal is approximately 100%. So it's the same code for something big like a load balancer, right? And again, this is talking about the eBPF program code, not what runs up on user space, but the program code itself that uses the ISA. All right, so that's the goal, is cross-platform eBPF or BPF program source compatibility, right? Could be different bytecode if it needs to be, but the original goal was source code compatibility. Okay. All right, next slide. I think I got one more. Yeah, that's it. Okay.
I think we have a couple of minutes for clarifying questions if you have anything. So either step up or get to the queue. I don't see anybody, Dave. Thank you very much. And I think, Christoph, you're up next.
Question, Eric?
Yeah, so Christoph Helvig talking about eBPF for NVMe. And I think we can just jump to the next slide. So who's heard of NVMe here in the group? Okay, that's quite a lot. Usually almost everyone knows it because I usually talk to storage people, but we'll get through it. So NVMe is basically what your computer uses to talk to any modern SSD. I mean, there's a bunch of older ones using different interfaces still around, but they're not. And the only one that's not strictly speaking NVMe that you get in a modern system is what Apple does, which is basically NVMe, but with a bunch of Apple tweaks because Apple is Apple. But basically every modern solid state storage will probably use NVMe underneath. And it's both the actual SSDs that are PCIe attached that you see both in laptops and servers, but also the same high level command set used as a network protocol over TCP, over RDMA, iWarp, and InfiniBand and Rocky, or in fact for people who really like old school storage networks over fiber channel as well. And basically it is the modern storage interface. So jump to the next one. And one thing that NVMe has looked into and has been doing for about 3 years now is something called computational storage, which is very misleading because generally it's neither computational nor storage. And NVMe at least called the command set computational programs. And the idea is that you are able to execute some amount of, well, some program that usually for it to be efficient shouldn't really be doing computation on the classic sense right on the storage device. So you reduce the round trips between the host computer system and the storage device. And that of course is especially useful for things that touch a lot of data, but don't actually do a whole lot of computation unless it's very easy offloadable computation. And this kind of was started by Intel and Amazon Web Services who brought in their idea, which was based around uBPF, which is one of these non-original eBPF implementations we talked about. And while that was being brought in, I did a prototype based on Linux, which really used the classic Linux style eBPF. And it turns out the models we had in mind were very, very, very incompatible. Now, in the meantime, that NVMe substandard is progressing, but without the actual user-defined programs, which eBPF was supposed to do, because it turns out we really had no way to have a quotable standard for eBPF. It was basically, okay, just do whatever Linux does or do whatever uBPF does, and nothing was actually very well documented in the kind of, at the kind of level required from a standard or industry specification. And another use case that came up a while ago is something in NVMe that's termed like adaptive multipathing. Actually, the name's even more complicated, but the idea is that especially when you do storage area networks, in theory also for locally attached storage, but it's not very interesting there, you can have multiple ways to reach the storage device. So you have two network interface cards that could use different routing to eventually reach the same system. Now, if your storage system is not actually a single computer, but a distributed system itself, which is very common, where you store data, replicate it, erasure encoded, et cetera, over many, many nodes that are internally connected by network again, what people do right now is they have a front-end node that the external consumer talks to over NVMe, and then it actually has to basically rebalance into the back-end devices. And people are looking into getting rid of this front-end node and doing application layer source routing based on the properties of the I/O And these are going to be extremely specific to the underlying storage device. It's very hard to put that in a standard because it's basically, for routing, use this algorithm that Ceph uses, which is one of the examples people have brought in, or of that particular proprietary Dell EMC storage device, which is even less likely to get into an open standard. So what we need to do to actually implement this properly is the idea that your storage device can provide a simple program to the client, which the client then runs to make these routing decisions. And of course, this is a giant security red flag if that is any kind of like normal binary program. So you need a strictly verified lockdown execution environment, which really is what eBPF is with a program type that fits this. And next slide. Oh, okay, now and another thing that is not actually discussed in the NVMe working group right now, but that has gathered quite some interest is there was an interesting academic paper that tried to downshift pointer chasing and algorithms like B trees for databases into the Linux kernel using eBPF so that you don't do the syscall round trip every time you jump from one pointer to another. And there's been quite some interest to actually even further shift it down into the hardware device, that you basically implement at least the read side of some algorithms in an eBPF program, download it into the SSD, and you can walk a tree or some other complex data structure in a single protocol round trip to the storage device. And all of these have in common that you really have two entities that need to completely agree about the program semantics, right? For the computational storage case, it's an application that runs on Linux, on Windows, on some operating system that wants to offload some of its work to the hardware. So the hardware from all kinds of different hardware vendors needs to agree on a single definition of the program and the instruction set and everything that all these programs are written to. And for the multipathing work, the same kind of boundary needs to exist between the client or host software, as we call it in NVMe, and the server or the NVMe controller, as we call it in NVMe. And that's it.
Thank you, Christoph. Again, we do have a few minutes. If you have any questions for Christoph, get to the queue or start walking to the mic while you get on the tool. Hearing nothing. Thank you, Christoph. Lorenzo?
Lorenzo Cody, obviously no chair hat on here. Just wanted to give a very brief introduction to how we use eBPF on Android. I think, we've heard a lot of really interesting stuff so far. I just wanted to maybe bring it back down to earth a little bit, sort of just an implementation that's in everyone's pocket every day. And just mention, like, why we got into eBPF years ago and why we think it's sort of so useful and so powerful. So the way we looked at it, and I think probably a lot of other folks look at it, is that you basically get full kernel performance but without having to touch the kernel. If you're like Android and you can constitutionally incapable of upgrading your kernels, this is actually really interesting because we still support 4.9, which is, I don't know how old it is, but it's basically, we have 10-year support timelines, right, for kernels. But it's not, I mean, you could do this with a kernel module, right? But what you can't do with a kernel module is you don't have a stable ABI that you can basically just compile your code once and then just run it everywhere. You get the stability and you get these safety guarantees because Linux has an in-kernel verifier where you know that your program can't actually crash the kernel or do anything bad, which is something you really don't get with a kernel module, right? So, and you also have direct access to interesting kernel functionality via helper functions. I can give some examples of what we do with them. And also you've got these constructs called eBPF maps, which allow you to share in-kernel information with user space. So user space can push configuration and user space can gather statistics by just reading these maps. And you can basically have information sharing. And so this is basically incredibly powerful. And the reason we got into it at the beginning was we wanted to replace these like 3,000 lines of out-of-tree code, which was doing socket tagging and powering some of the network stats APIs we wanted to get it, you know, delete the out-of-tree patch basically. So we essentially replaced it with a very small BPF program and a very large user space component. But that was expected. But that's kind of the goal, right? If you talk to the kernel people, they're like, get out of my kernel, right? And so that's what we did. So next slide, maybe. So yeah, just very briefly, what do we use it for? Well, basically everything, right? So every packet through the networking stack goes through BPF probably at least once, right? You know, we use it for data usage. That was you know, if you go to Android data usage screen, the data there is you know, collected by an eBPF program. And the same program, I think, actually also does firewalling, does when your app goes into the background, it starts dropping its packets. When you turn on battery saver, it drops the packets. That's also on the BPF code. We also have, you know, anything that needs to be high speed in particular regarding forwarding, like tethering or 464X-LAT, stuff that the Linux kernel doesn't support inherently, you can do it by BPF because the hooks that we have are powerful enough to do that. So we use TC-BPF for 464X-LAT and for tethering, and you know, it's kind of amusing. You've got this little pixel device, right? And it can do 4 gigabits, and you're just like, why would I ever do this? But it can do 4 gigabits of tethering if you plug it into USB 10 gigabit USB. So, and yeah, network tracing, that's a recent addition where we use the ring buffers, and lots of other stuff, you know, like for example, the modem wants to reserve UDP ports, and we use a BPF program for that because you can attach a program to the socket create call, right? DHCP remarking and so on, and trace points. So yeah, I just really wanted to point out how this is like really concrete. We've actually been doing this for years, and it's incredibly powerful, and just wanted to be a little bit more concrete. But I think, yeah, that's it.
I think we're done with the overview on the technical kind of parts of the presentation. So just want to take a small pause here to see if there's any questions from anybody in the room or remote. Okay, so not hearing anything. So just kind of like, you know, moving up a level into like higher layers of the protocol stack to start looking at like what the eBPF Foundation thinks. So just try to bring up like Dave and Alexei up to the stage so we can go through the eBPF Foundation's position on this, because I think some of the questions that came up earlier when we have a side meeting last time was like, what is the eBPF Foundation thing? Why do they want to bring it here? And those kind of questions, kind of get it out of the way before we start the discussion on bringing the work to the IETF. So Dave, start us off. Thank you.
All right. Sure. eBPF Foundation is an organization created underneath the Linux Foundation. The first line of the charter says, the purpose of the eBPF Foundation is to raise, budget, and spend funds in support of various open source, open data, and/or open standards projects related to eBPF technologies, including infrastructure and support initiatives related thereto. That's the purpose of the foundation. All right. So a bunch of companies got together and says, we would like to fund people that do things that promote the BPF ecosystem. And you see in there, it's primarily open source, although you see open standards projects as being something that could spend funds in. Okay. So that gets in the question of, okay, what can it do for standards? Okay. So eBPF Foundation is clearly interested in the notion of standardization and wants to make sure that stuff is standardized someplace. Okay. It would prefer not to be the standards organization itself, okay? Although that is an option if everything else falls through, right? It's probably not the best option, right? And so the technical body called the BPF Steering Committee, there's currently 7 members and 4 are represented in this meeting. And so if you go back to the title slide for a second, I just want to recognize the BPF, the title slide. Those are the 4 people out of the 7 that are actually part of this meeting. Joe is remote. And so Alexei and Daniel, where'd Daniel go? Yeah, over there. Right. So the 4 of us, Joe being remote, have a majority of the technical body of the BPF Foundation. So if there's any questions for that, we have the participation actually in this room virtually. Okay. So go ahead and go back to the next slide. Okay. So the foundation wants to ensure that a standard is published someplace. Okay, you saw all these different ecosystems and uses all trying to do it, doing it the same way. We want to promote the fact that there's one way to do it. There's a specification that people can depend on from other organizations. We've seen a bunch of IETF groups using it in implementations and potentially specs. And certainly the BSC members in the community are willing to participate in IETF, as you can see from the presence here in the room. A bunch of them came specifically for this meeting, came to the hackathon. I would say the general feeling I get is that they're willing to come here and participate. And I'm kind of sitting in both camps myself, but speaking on behalf of the rest of the members and stuff, right? They're coming here, they are participating. This meeting right here is the union of both communities right now. So we don't have to say that's them, it's actually us, because we're both in the room here, IETF and the BPF community.
Thank you very much, Dave. If anybody has any questions for Dave. If anybody has any questions for Dave, please come up, because I think it's important, like this statement from the EBPF Foundation, and please come up. So Charles, you're up first.
Can I make one other statement here? Sometimes, but not always, charters mention, and this group will interact with such and such other group, right? I've been in various other working groups that bake into the charter. Oh yeah, we need to interact with, IEEE or interact with W3C or whatever, okay? I think in the draft charter, it mentions EBPF Foundation in the draft charter, and that's why we put this up here, to say if you think that should be in there or not in there, this is why it's in there, okay?
Charles Eckel. So I'm really excited to see the EBPF Foundation bringing this into the IETF. You've already addressed most of my major concerns. One thing that's still in the back of my mind is when there's some real contention over how to proceed with the standards, and we're trying to achieve that standardization within IETF is going to result in slowing things down a little bit, say, in terms of how fast the EBPF open source community would have moved in the past. I think that slowdown is valuable and worthwhile, but how do you see that playing out, and so that the open source doesn't just get ahead of the standards, and then really what we're doing with the standards is just sort of documenting.
So that's more of an open mic question. I can speak as an individual and this has to do with what is also in the draft charter text, in case you have thoughts on how to modify it, if you can think of a way to improve it, is that part of the goal of the proposed working group would be to define what the process is for somebody that wants to do an extension. Okay. And so is there a vendor space or not, right? What do you have to do to define an extension to fit within the rules? Is there some code point? You need to get anything finite, whatever it is, whatever we want the rules to be, okay? And so initially I would say whether it's, Linux, Android, Metronome, anybody else, if they want to do some extension, they can bring it here. Or if the rules allow it, they could do an extension here. And we, the working group, if it gets chartered, would be the ones that get to decide what the rules are for, are they allowed to do that or not, okay? And so can it slow them down? Well, if we specifically allow an extension process that is acceptable to whatever the community is, then that's how it would be done. But that's the job of the working group to define what that process might be. That's my opinion.
That makes sense, Dave. So I think the idea is like part of the deliverables of the working group to do that, right? But the idea would be the work will be funneled through the IETF, like instead of like trying to have a fork going in kind of parallelly on the kernel side. That is kind of like the higher level goal.
If you want it to be standard, right? That leaves open the question of, do we want to allow any vendor extensions that are not standards, right? That is something that the community can decide, that I don't want to presuppose the answer to that, right?
And even in any other standards, the implementation can sometimes be ahead of the written standard, right? As part of the interoperability testing and so on.
Very, very common, yes.
David, go ahead.
David Lamparter. I have a strong suspicion that the IETF is the best standard organization to do this in. But for the sake of completeness, did you consider other standard organizations? Could you give a little bit of context?
Go for it.
Unless you have a slide later, then yes. We had a side meeting at IETF115 that was fairly widely organized, right? I advertised it in like the int area meeting and the art area meeting, which is pretty broad. So then we had a side meeting that was fairly well attended from both communities, both remote and local. And we talked about that. And the four at the time of IETF 115 that were on the table were IETF, just doing it inside the EBPF Foundation and having documents come out of that body, okay? Taking it to ISO maybe after doing it in the EBPF Foundation, and just taking it to the independent stream. Okay, those are the four that came up then. A fifth one has been added as a possibility that's been discussed since then, is if the IETF didn't do it, then OASIS is another possibility, right? Now, I'm with you that I believe that IETF is the best place, but those are the ones that have actually been talked about, to answer your question.
Eric, before you go, just like a point of orders, like, at this point we're opening up the mic. So like, if you have any kind of topics about anything, just come on up, right? Like, and we can handle it. Like, just get on the line.
If it's for me, ask me. Otherwise, I'll go sit down.
Yeah, that's fine. Yeah. So, Eric, go ahead. Thanks.
So Eric, not Mark. So about the foundation. So I assume that there's a question about exactly what's in scope for standardization or what is useful or whatever. Does the foundation have any opinions about this? Sort of, here's the package that the foundation thinks makes sense?
I would say that the individual members of the BPF steering committee, the majority of whom are in this meeting, absolutely have views on that. Does the foundation as a whole?
1 year, multiple years?
The foundation as a whole was formed, a little less than 2 years ago now? Does that sound right? And so we can't necessarily say the foundation has a formal position that's published, blah, 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 because it's new enough that it doesn't have that. We can just say the members that would be doing that are actually here in the room, so.
Okay, that sounds like a topic we should talk about. So.
Yeah.
Thank you, Eric. Jeff, back mic.
I am Jeff Haas. In IDR, we work on this feature called FlowSpec. That's used for sending around little firewall programs around routers. One of the bits of advice I want to offer, especially ADs, chartering entities here, spend a lot of time in your charter discussing what you want to do about your security considerations for this stuff. This is obviously a very generic tool that can show up, anywhere from a bit of injected code, maybe all the way out to protocols injecting things as programs into the network as a whole. I'm sure you're going to see a lot of things in that space from a lot of people in routing over time, and you're going to find that there's an immense amount of pain there. And please spend a lot of time on this.
Thank you very much, Jeff. And that was not the only reason we thought of IDR. The other one was the multiple interoperable implementation stuff. So that's certainly something that we talked about earlier. So thank you for pointing.
Yeah, and NPCE obviously is another example.
Thank you.
Christoph's presentation alluded to that factor as motivating why a verifier is super important in the NVMe case, right? And if you saw the list of potential deliverables that Alexei showed, that's why that second bullet is there, right? The verifier expectation, what is it that's the safety considerations you need to make sure are true? And so, yes, absolutely spend a bunch of time on that. That's super important. That's why it's on that list. So thank you.
Thank you. Thanks, Jeff. Lars, go ahead.
Yeah, Lars Eggert speaking as an individual. So I want to get back to Charles's point, which sort of my summary was like, what if the implementer community gets fed up because the IETF is so slow? I think that's what you try to ask, right? You were just nicer saying it. And I think the IETF has sort of these two things, right? One is the rough consensus, which is maybe sort of our part here, right? That the implementer community needs to understand will need to happen for the standard to go forward. And the other part is running code, which is really coming from there. So it doesn't make sense really for the IETF to try and standardize something here that the running code part says no, can't do or won't do or whatever. And also it doesn't really make sense to talk about standardization and still wanting to run ahead of the standards process. So there's a little bit of a give and take here, but I think that's understood that that's gonna need to happen, right? Thanks.
Yeah. Some working groups impose a rule. Yeah, you got to have 2 interoperable implementations or something like that. So if this becomes a working group, then this working group can decide what rule it wants to follow, right? Does it require an implementation? Does it require multiple interoperable? That's up to the chartering and process we decide. So if this goes forward.
Thank you, Lars. Just like one point to add on that, right? A lot of the contributors on the kernel side are actually here as well. I think that's going to really help with that. And I do understand both your and Charles's concern, but I think there's a lot of things going for us this time.
Is there anyone who would like to stand up and respond at this time, or do you want to leave that to the open mic? I'm looking at some of the implementers right now. No? Okay.
You can leave it to later. Okay. Joel, go ahead. Thank you.
Hello, Joel Halpern with Ericsson. I am going to take a somewhat unpopular perspective here. I do not think this work belongs in the IETF. It appears to be wonderful work. I'm really impressed with what I saw, with the uses, with the power of it. Looks wonderful. It is not IETF work. We don't standardize programming languages. We don't standardize compilers. We don't even standardize verifiers for programs. I might be tempted, although out of courtesy I probably shouldn't, but I will anyway, to argue that the experience with IDR of specifying FlowSpec demonstrates why the IETF should never touch programming languages. We made a complete mess of it. It works because, well, we can make pigs fly, but it really is a demonstration why not to do it. It looks like this is wonderful work. I'm sorry you're having difficulty finding a suitable home to do the standardization. I understand why you want to standardize, but as far as I can tell, it does not fit with the IETF approach to standardization and the IETF subjects for standardization. It is not about the communication between distinct entities. It's about what's going on to program a device to process packets. I had to recently explain to a guy in a working group I co-chair that his architecture document was an interesting document about the architecture of the inside of a router, and we do not standardize the inside of a router. So it looks like great work. Good luck finding a place to do it.
Clarification question. It would be good to know which specific failure modes you anticipate to see, in what ways we fail. Like, do you think we have the wrong people, or and so on and so forth, right? Because like saying an organization is capable of X, Y, and Z, it's sort of like kind of abstract because the organization is made of people, right? So it may be like, you know, also like there might be things that happened a while ago, it failed in ways that we don't think will fail. Anyway, so it would be nice to have a bit more detail, maybe not here, maybe on the mailing list.
I probably should discuss that on the list. I don't have detailed answers. What I would observe is when we have wandered out of our charter, we have often found that difficulties either in short-term or long-term. Sometimes it's long-term difficulties, sometimes it's short-term. Our oversight processes and our AD selection processes and our review processes are not well suited to making sure that, for example, well, this is actually a verifiable, I mean, I'm imagining an IETF last call discussion of whether this instruction set is verifiable. It can't happen. It's not something we can do. We have trouble with security stuff in general, but we have ways of dealing with it because we do have to do it. But this seems to hit a lot of the buttons where things go wrong. I'll have to think about how to elaborate that in a fair way on the list.
Thanks, that's helpful.
Thank you, Joe. Thank you.
David Lampotter. I was going to make a slightly different point, but I'm going to adjust it to Joel's comment. I do want to be able to carry BPF programs between different things and platforms, which is what puts this into scope for IETF for me. And that's also where we've hit our limitations when we were looking at this, and this is going to echo points from Dave and Christoph earlier. The verifier is the ultimate stumbling block that you hit upon. And we had exactly the same problem. It's not sufficiently specified how to do this exactly, what should be accepted, what shouldn't be, and that is the trickiest part. It's also the most important part because that's what makes it possible to use this for those cases like NVMe and allows you to carry the stuff between platforms. So that is really the most important thing that I see to do here. Try and figure out how we are able to verify things and make them in fact portable between systems.
Just before you go on, Eric, like Lars, would you like to use like an IETF chair trump card or something to do it? Okay, thanks. Go ahead, Eric. Thank you.
Do I have one of those? Don't you have the pocket full of them? So Eric, not Mike. Yeah, so sort of Joel's comment, I know that I think I recall having had similar discussions in other BOFs over the decades, but I think the key thing to me is, you know, are we competing with somebody, some other SDO, or do we have the do we not have the expertise, right? And I think that there clearly are failure modes where people hear there's something that's useful, but they don't necessarily have the expertise, right, to either specify and or review it. And in this space, well, are the people here that know how to structure an instruction set for a virtual sort of processor, whatever we should call it, right? Well, probably not today. Will there be, do we need enough of that? Or are there people that are going to come here as part of this to do that type of review, right? Likewise, on the security side of things, I think there's a fair question saying most of the people in the IETF that are active understand communication security, right? Protocols and things, and know how to plug into the various algorithms that mathematicians might develop, and some of them might be here as well. Do they understand enough about sort of system security to go and review this, right? because I think that we have lots of expertise in the IETF. You know, do we have enough coverage for this stuff? Will people actually come here if we pick up this work? That, to me, that's really the essence of the question, not saying that we have failed in the past. Well, that's no reason to, we need to understand why, right? And then figure out, okay, what can we do in a case like this where there's clear utility, but to make sure that we don't fail again.
Thank you. Eric, Lars, like, can you let Eric use like a...
Okay, you can.
Thanks.
To take
Eric
an
Klein?
AD point of privilege, I think it might be useful to clarify work that basically already exists from work that would be done in the future. Because there's a certain amount of stuff that already exists that would go through a standardization process, and then after there's things that don't exist yet that would be developed. So it might be helpful to understand which sorts of things are in which camps, and some of those things would help clarify short-term versus long-term failure modes for Joel's concerns.
Thank you, Eric. Lars, sorry about that. Thank you. Go ahead.
Yeah, Lars, I was going to say something similar, that at some point we should probably look at the charter text, because I think the list of deliverables is pretty uncontroversial, right? Also, in terms of having had the pre-BOF discussion, right, we actually did take a look in the IETF and to see whether we had published something like this before. Specifically, I think we looked at the instructions, and it turns out we have, right? You didn't present it, but was it ROC or SIGCOMP or something? We did specify an instruction set for header compression, right? Which is also, we could have, like, you remember. So it's not something we do very often, right? But we have done it successfully at least like once or twice in the past. And there's some other related things. We did something like an ECMAScript, or I don't know what it was, right? To Joel's point, right? I would half jokingly argue that IDR failed because they really don't have that expertise, right? But this is a different setup. This is actually a community of experts that want to come here and work here and bring that, right? Which I think also Eric said, right? It's a very different setup in my mind. And frankly, the IETF needs to be very open to new work, because we need to broaden out, right? We need to attract new work that's hot in the industry that people want to do, right? We can't say, this looks like strange and no, go away. I think that's not a path forward for us as an organization.
Thanks a lot, Lars. Thank you. Dave?
So Dave Thaler, I came back here because the questions were not for the foundation, right? So I just got inclined to speak as an individual. So I now have three things that I want to respond to based on the conversation now that we've got up here. So I am usually in other working groups the first person that comes to the mic to say, the IETF doesn't do programming languages or whatever, go for this thing, go to this other body and so on. And here I want to say why I think this is a different case than what I usually do, because I actually am being consistent in my arguments across working groups. When there exists another body, okay, then we don't want, and this was the point that Eric Nordmark was making, right? That we don't want to compete with them. So if you're going to propose something for C, right, you go to the Austin group, the POSIX community, right? If you're doing something for JavaScript, you go to W3C and so on, right? And so if there's a body that's already there, don't bring it to IETF because we're not the authoritative body for it. That doesn't apply here, right? Because there isn't another body. It's like this isn't a special case there. I'd make the same argument for any other language. It was a special case that was designed for this. There's no other place to go, right? So that the reason that I normally say go elsewhere doesn't apply. The question is still valid, right? But that's so the second point, back in 2008, IETF 73, we had the IAB plenary had a presentation about evolution of the IP model that later became RFC 6250. The summary of that discussion in that RFC is that the IP model keeps evolving. It's not just one fixed thing for all time. And one of the recommendations that came out of the discussion there that appears in the RFC is that lower layer protocols should document the contract they provide to higher layers. Okay, so how do you document that? An example that the IETF has done that kind of fits into there, except for you can argue maybe it's not upper and lower, it's sideways or whatever, would be GSS API. So in the API discussions, I usually say if you're doing an abstract API, we got that's great, right? TAPS and GSS API, you have a formal way of documenting your contract between components. In one sense, you can think of the bottom bullet on Alexi's slide about the cross-platform helper functions as a way to formally specify the contract between two components. Okay. And so that's why that could be in context, in scope for the IETF. Then lastly, audit different bodies, where are the experts? I think there's evidence that we see in this meeting and the past side of meetings that the experts are willing to participate in IETF. I don't know if that's the case for other places. I know certainly for me personally, it's a lot easier for me to participate in IETF than other places. And then the last point, if I look at Lorenzo's slides, he talked about how pretty much every packet goes through BPF at least once, okay? And so if we're talking about things that are just core TCP/IP functionality and networking stack, it's like the biggest piece that's not already in the IETF, right? Everything else that it goes through is typically in the IFS, but that one isn't. And so I'm convinced that the IETF is the best place for it. So thanks.
Thank you, Dave. Christoph.
Yeah, so I'd like to reply to some of the arguments from Joel. So the one interesting thing is that the original, even the original eBPF use cases in the Linux kernel, or as a variant of that in the Windows kernel, it's really two separate entities talking to each other, right? You've got your unprivileged user program that is able, or less privileged user program, that is able to do work in the context of another software entity, the kernel. And now if we go into our NVMe use cases, it is literally going over network, either a real network in NVMe over Fabrics over TCP or RDMA, or over PCIe, which really is a packet switch network underneath that's just really trying to look like an old school IO bus. And you're offloading a program to another entity on the other side of the network, and it is really relevant to things like network security. And that kind of gets into the next point, that eBPF came out of networking, still has a lot of networking focus, and actually having that networking domain review in IETF is very useful. And if you compare it to other standards organization, like if you look at NVMe, or if you look at the T10, T13 bodies that do ATA and SCSI or T11 for fiber channel, they don't have that out of specific domain review at all. It's not like you get better ones in other standards organization. In most of them, you just don't get it at all. And this goes to the extremes of something like Oasis that just rubber stamps whatever you bring to it, which is also not very useful.
Thank you, Christoph. And for the people who are remote, that's like David Vernay. He's new to the IETF, so I'm not going to give him grief for not using the on-site tool. So, hey, David, go ahead.
Yeah.
Not
So
this time.
Hi, everybody. I'm David Vernay. I'm a Linux kernel hacker, and I definitely don't have any experience with standardization. But what I can talk about is what's happened in industry with BPF and why I think that a standard is very good for BPF and for the tech industry. So there's already one company, Netronome, that has BPF offloading support. And there's at least two more that I've heard of that are interested in adding it or actively adding it now. I would say that the fact that hardware vendors are building ASICs and stuff like that to support BPF offload is pretty strong evidence that there's sufficient room for finding a stable instruction set and finding consensus on some of these finer points of the verifier and the runtime environment. And most importantly, a lot of these conversations will take place because a vendor will reach out to somebody like Alexei or Daniel, one of the maintainers. And I think that those conversations would be much better served in an open forum where you can have multiple companies, multiple interested parties weighing in. We want to fix mistakes before we implement them and before we add them to UAPI, as Alexei said, where we have backwards compatibility concerns. So yeah, I don't have the experience of a standard to talk about whether it's appropriate or not for the scope, but certainly the public forum of a standard and the idea that we have everybody participate in the discussion is by design. And the last thing I'll say is, yeah, the fact, I'm excited to participate in the process. Obviously there's give and take, but definitely as far as being a contributor, it's great to be here too.
Thanks. So Chair hat off. Just wanted to say it, again, as an individual, I think BPF is reaching the point in its sort of evolution where, it needs to scale beyond its, its sort of original first targets, right? And I think, if we want to scale it to whatever 10 NIC vendors, right, maybe we'll need a standard, right? And I think the folks involved in this that have been developing it since it started. They're here. Maybe they realize that it would be good for them to partner with people who do know how to do standards, right? I think we can definitely for all we can poke fun at the process, right? But I think we do know how to do standards here, and I think we can really contribute. And I think together, and to Joel's point, even right, like together with the domain experts, I think we really have a good chance of doing something really good here. So,
thanks, Lorenzo. Colin, go ahead.
So, Colin Jennings, I'm definitely in favor of doing this work here, and I want to speak to why on the expertise type thing a little bit. I think that if you look at the protocol and things we're defining here, it's not deep, dark, complicated, advanced edge of choosing instruction sets for very wide word processors or something like this. This is a very straight up, common, basic sort of thing that's well understood at this point. And what we're adding to it actually is things that very much are in the IETF domain. There's like, well, we should have a network to host byte order type thing. The fact that's an instruction is very IETF-ish. The fact that this is going to have to map to our ideas of sockets and profiles and all of the things that you want to optimize in this, I think we do have a lot of expertise in. And the areas outside of that, yes, people will come with that expertise, but it's also not super advanced versions, leading edge of it, sort of common sense. And if you look back at our SIGComp experience, which also defined a fairly complicated programming language for doing compression at the IETF, I think that met the needs quite well of all the people that wanted it and needed to use it. I don't think it turned into a disaster at all. So I think we have a history of track record of success in this space, in fact, at least in some areas, perhaps not others. I don't know all of them. So I really don't see a problem with this. And I do think we have to be able to expand into this type of space. And if people are, want to bring this type of work, want to do it here, we should do it.
Thanks, Colin. Andrew?
Andrew McGregor, Fastly. I think it's certainly time that this got standardized somewhere. And here, I think is as good a place as any, because there's a substantial chunk of BPF's user community here as well. There are multiple operators of big fleets that do BPF on at least every connection, if not every packet. I looked through the slide showing the program types and realized that, well, I know of programs at Fastly that use 11 of them and 2 more in development. So, and storage, okay, that might be us actually. But there are certainly other folks around here who run data center type operations who would be using that. And so, yes, user community will be here. The developers seem to be motivated to come. I think it can be done here and should be done somewhere.
Thank you. Thanks, Andrew. And I think like one of the things that also came up in the chat, so Daniel brought it up in the chat as well. So thanks, Manu, for like looking at the the hackathon from previous time. And so there's like a bunch of work that actually uses it to the point like Andrew brought up, right? Like, so there's like technologies here that are actually using it for prototyping, IETF protocols, and so on. Not that this is like a smoking gun, right? It doesn't conclusively prove anything, but it's like there's at least some kind of linkage. Like, so here is as good a place as any. It's like the slogan of the day, Andrew. Thank you. Kono-san, and that's Mia Kono-san.
Yes, Mia from Cisco. Well, I just wanted to add a comment that the IETF's bottom-up declarative approach is suitable for the eBPF standardization work if it's needed. So I really agree to other persons who will include the eBPF work as well. And I'm also wondering that the other stuff like service mesh could be included in IETF work if there is some need for standardization. Thank you.
Thank you, Kono-san. Hari?
Hi. Hari from Netflix. Netflix is also part of eBPF Foundation. So trying to understand how, what will be different in Netflix, eBPF Foundation if things are happening in IETF? As in, like, is there anything that's going to be not happening in eBPF Foundation?
So if the question is there anything that will not be happening in the eBPF Foundation? Yeah, the eBPF Foundation will not have to get into becoming a standards body and can just promote and fund open source projects, and the extent if there's any funding necessary for standardization, like if somebody has to be a document editor or something, then and they need funding to do that, then that would be something that could come to the foundation and ask for those funds, right? We don't have any policy for that yet, but you can see our charter is to support in whatever way we have funds to support open source projects and standards, right? But we don't want to necessarily create a standards process, right? We much rather come to IETF, which has a well-defined standards process that we participate in. So is there anything we wouldn't have to do? We wouldn't have to do stuff that we really don't want to get into, right? And just focus on the stuff that we want to get into in the foundation. So other foundation people will feel free to disagree, but that's how I would summarize it. So, okay, I see a nod. Okay.
A follow-up question. So the technical steering committee in eBPF Foundation is supposed to steer, where what are things that's going to happen, right?
The foundation has three main bodies. There's the governing board, okay, which deals with the charter and the bylaws and budgets and so on. And then underneath that, there's the BPF steering committee, which is the technical body. And then there's a marketing body. The marketing body takes care of the flyers and logos and event plannings and things like that, right? And so they would focus on the event planning stuff. The steering committee would continue to have discussions around technical futures and coordination between event bodies and brainstorms about future and stuff. Some of that discussion could become in the IETF if there's a working group for it, right? And so is there anything that wouldn't do? There's probably more open places that some of the stuff would move to be even broader or whatever, which is great because, more community is better, right? The more broad the stuff gets deployed, that's what we want. So
thank you.
I mean, some of the key contributors would still be members of the foundation to provide some technical oversight for things like open source projects that might be funded by the foundation and so on. So at least that's my take.
Thank you. Thanks all. And the queue looks drained, so if you have anything at all to say.
There's two people in the queue now.
Okay.
One person.
Okay.
Let me move that.
Okay, go for it. Thanks, Daniel. Go ahead. Monsieur Bernier?
Wait, am I supposed to do that here?
No, it's good.
Can you hear me? Sorry.
Yep, go ahead, please. Thank you.
Okay, so on the chat, I was saying I will maybe it would be interesting to have a better view of what's the expectation of what gets standardized out of IETF work. So the reversed, so having more eBPF injected into IETF, I think is actually really interesting and more than welcome, because it's going to help promote even faster some of the work being done here. But I'm really curious about the other way around, because one of the benefits of eBPF is the fast adoption it gets and the fast development gets out of the way the ecosystem works. So I'd like to see what needs to be so standardized that really warrants to be done at the IETF, or could not be done in another forum, like it's done for example, I was saying on the mailing list P4 or any other data plane programming. So.
Dave, Alexei, did you get that question, or would
let me rephrase the question. I think it was, please correct me if I'm wrong, but what I heard was primarily, what are we actually going to standardize here? Is that right, Daniel? Yeah, I was looking for Lexi's last slide, but I just closed it, so sorry.
No, I saw the last slide, but the question is,
so here's the slide on the screen. This is
some
things that we thought, that Alexei thought should be verified. It should be standardized.
I think like Daniel's question might be subtly different from that. I think why don't we do it elsewhere because it can be done faster? Would that be a good summary, Daniel, or no?
Yeah, elsewhere on like map types, namings. Right. Pretty wondering.
Where? It doesn't matter. That's the question, right? So I think the thing is, I think it part of came up in Dave's presentation as well, right? Like it needs to get done somewhere, and this seems like good place to do it, like based on the linkages to the other protocols or not. But this is certainly not decided, right? Like, so that's why we are here trying to see if this is the right place to do it. And I personally am not worried about the velocity of the thing, because it's the same people who are like working on the Linux kernel stuff right now who are coming to here to do this, right? And part of it is to stabilize a baseline so that the extensions can happen. And that's kind of where we can set the, I would say the right procedures for having velocity or not, right? Because I think there's some kind of compromise to be had between how quickly we do things and how stable things are at some point. So I think that's something the working group can decide, how like fast and fail fast kind of things we want to do, or how stable we want to do that, right? I think Christoph alluded to it in some of his stuff as well. So that's something certainly open for a working group if one gets formed.
Yeah, and also like we're going to be talking about the sort of suggested charter shortly, but I think also, as part of the chartering of a working group, we get to decide what balance to spend on stuff that already kind of is deployed in production and, in the billions, and, stuff that needs to be sort of standardized. It's blue sky and it's 3 years away. So there's in the sense that, if folks are concerned that we can't keep pace or we can't actually have a good working relationship, there'll be plenty of existing work that we can slog through first and see if we can really build a solid collaboration with the two communities. And that will give us confidence that we can then work on sort of more blue sky stuff later on. Daniel, does that answer?
Yeah.
Yes, thanks.
Okay, thank you, Daniel. I'd love to have more discussions on this. Thank you.
So Antoine?
Antoine?
Hello, Antoine Franco. I must say that I agree with Joel Alpern first. I have a question regarding what will happen if a technical item is standardized in IETF and the eBPF Foundation is not happy with it. It questions the role of IETF and eBPF Foundation. Do you see the role of IETF as a recording chamber for the technical work that is carried out in the eBPF community? Or do you think that some work that is carried on in IETF will be translated in the eBPF community later if it's relevant to some use cases, service providers, vendors, whatever?
Could I ask to clarify one point?
Yes.
You mentioned, what if the IETF standardizes something that the BPF technical developers don't want?
Yes, because it may happen. If discussion happen in IETF and we build a community that can be different from the BPF.
So just to clarify, that the developers that disagree with this would be part of the community.
Yes.
So in your hypothetical scenario, they'd have to be declared in the rough. And as potentially the maintainers of the largest implementation, we would basically want to override them. So, but just, okay. Yeah. Just to clarify.
You phrased the question differently, so I'm going to answer your question, and then I'm going to answer the other question too, right? Because you asked about the eBPF Foundation. Okay?
Yeah.
I would think about it as there's not two communities, there's only one community because they're all in the room right now. Okay. And so if there's eBPF Foundation people or NVMe people or whatever else that disagree, this would be the place to have that discussion. Okay. The eBPF is a funding, or eBPF Foundation is a funding organization. Okay. And so I said, doesn't matter if the eBPF Foundation as a whole, because that's really funding organization, right? The more interesting question that you could have asked is, if the Linux kernel community disagrees, that's a different question, okay? And now I can give you the same answer, but not all the Linux kernel community is here, but certainly the BPF maintainers are, right? And so that's why the question I think you should have asked, and that's what Lorenzo is answering.
But then if this happens, what will happen?
Same as on any other RFC that gets implemented in Linux. Same answer. It's nothing special about BPF.
I mean, chair hat completely off, thrown away out the door, but like, I've never seen that happen at the IETF. You get 3 people that disagree with you, you're gone. It doesn't get standardized. Again, the chair hat is all the way over there.
Yeah, I did sort of address that in answer to somebody else's question when I said it's up to the working group if they want to impose a rule that says you must have at least one implementation or at least 2 interoperable implementations. Things like that's very common in the routing area, for example. We could impose some rule like that that says nothing gets into the standard unless there's interoperable implementations, and that would kind of force it, right?
Okay.
Yeah, Antoine, and not to beat a dead horse or anything, right? But I think the point here is at least something mechanics wise. Let's not put this too far ahead of the stuff, right? But I think part of this thing is to see the change control to IETF. So maybe there's going to be something in the Linux kernel tree that's going to say the changes for this is going to come through the IETF process, right? Maybe people will be happy or not, but the goal is not to have 2 diverging set of implementations going forward. I think that would be our goal. How it works is something that's up for discussion, right? But the goal is not to have 2 parallel development trees, one where the Linux developers don't participate here. The idea would be everybody who does this participates through the IETF process. Since we have an open process, mailing lists for everybody, just people come here, try to bring the extensions, follow the governance process. We establish here in the working group for doing that, or proposed working group for doing that. Thank you.
Yeah. but it also stems from the observation that in open source, there is nothing as easy as making a fork. So in fact, this is the contrary of having a common set of standard instruction if you have so many forks. So that I think this is a question that needs to be raised. Development and open source software is very different from networking standardization, and this needs to be taken into account somehow.
Thank you, Antoine. I think Lars is going to use his card now.
No, I'm not. I'm just nicely asked whether they mind if I reply. So Lars Eggert, sorry, I'm jumping the queue a little bit. So I mean, there's an understanding that by doing the work here, that IETF processes apply, right? I mean, that this is sort of, I'm saying it, but it's obvious, right? That'll need to happen because otherwise it's not a working group, right? That said, right, IETF working groups sort of disregard the opinions of large implementers on their own peril, right? Because it brings us back to the running code, right? I mean, in a hypothetical case, right, we have a bunch of people that come over from various implementers. We start a working group. We might have IETF participants that aren't part of that set, join the work, become interested, make suggestions, and maybe raise objections, right? If they're justified and valid, I'm pretty sure everybody will be very happy to incorporate this, right? Because it makes the output better. But there might be valid reason that you know, why these things might not be incorporable. Oh man, I'm on a roll today. And that needs to then be worked out, right? Because, you know, we discussed this a little bit offline, right? I mean, if there's like a fork, or if there's a fundamental disagreement here, right? What will happen is that the IETF keeps working on whatever it's called, and it won't get implemented. It will be ignored in the market and by the vendors, and they will basically do it somewhere else, or doing it in another way, right? So this is what has happened before in the IETF, and this might happen here. So we got to understand, right, that we need to work together on this, and I think we have an interest to do so. And so I don't really see this fork failure as a possibility, but it has happened in the past. It could happen here. I hope not.
Thanks, Lars. Christoph?
So I was actually going to reply to the comment before that, but it actually blends into this one. Can we jump back to the standardization items? Because, I mean, if we're looking at the scope and the initial charter, this
It's just slowly moving.
and if we look at the first 4 items, right, this is stuff that's already out there in multiple interoperating or more or less interoperating implementations. And a very important bit is to finish actually documenting it and making sure they're not just more or less interoperating, but like 100% fully interoperating and fleshing everything out. So this is stuff that really needs to go into internet drafts and is really the urgent part. Now, if we look at the last item with its sub-items, this is more of quote unquote an application layer where we have lots of alternatives and not just the single canonical one, different program types, different map types. And this was kind of getting into the previous comment. I can see a lot of like vendor specific fast innovation, especially there. That doesn't mean things like the instruction set don't change. Alexei mentioned there is actually things going on there too, but they're much slower because it's much more fundamental low level. And for example, for NVMe, we would totally define the program types downloaded to a storage device in NVMe and not in IETF because it doesn't make sense. On the other hand, networking specific program types absolutely do fit into IETF, and Linux specific program types that are fully Linux specific, like all the cgroup stuff, they will probably forever being continued in the Linux source tree. And if there's ever Windows specific ones, they will just be documented by Microsoft. So we have this like very core level infrastructure that a lot of people are interested in that is generic and shared by everyone that we really need to come to agreement on. The good thing is the different communities are vaguely in agreement already. So this is actually not that hard. And then there might be extensions to that for which I think a proper standards process is very, very important for quality. And then we have all the interesting things built on top where some of this might end up being in the IETF, especially if it's networking related and portable, and other stuff will just stay proprietary to implementations or be in other standards bodies that make use of it.
Thank you, Christoph. Dave?
David Lamputter. I'm really just going to beat a dead horse here and bring you more reasons to take this into the IETF. people have been coming to us asking to load BPF programs into the routing plane. They want to affect some specific bits about how the router picks the whatever. And they want to use the same BPF program in several implementations. And that is very much an IETF thing. And BPF is the language of choice for that. It has the longest prefix match as a function. It's portable. It has a verifier. I think this is appropriate here. And yeah.
Thank you, Dave. Andrew?
Andrew McGregor. I think the IETF has something to add to the last couple of points there too, the section naming conventions and the architecture. And that is, we have an established process for avoiding name collisions. Right? IANA registries could be really helpful here.
Thank you, Andrew. Matt?
Matt Joris, Meta. I just wanted to address a point that's been brought up a couple of times, which is about this conflict problem, like the forking problem, and as if this is like a new problem to the IETF. And I just wanted to, Dave already mentioned this, but I wanted to point it out again. This is a existing problem. We already have existing standards and protocols that have very large implementations that can decide to do whatever they want, and screw the standard process if they don't care. Like it's you say you bring something for standardization and you say, hey, we want to standardize this, and then let's say the consensus is such that, oh no, we don't want that. We already have the problem where those people can go away and flip a significant portion of internet traffic to use that new standard. It doesn't really happen that often though. And I think this is just another example of that. So we actually can solve that problem. It's a social problem, but it's a solvable social problem.
Thank you. And I think the point was, like, the conclusion was that the risk is lower than normal here, right? Because the implementation community is also here. So thank you. Thanks.
Yeah, it does actually, though, inform, I think, what we need to think of as the charter, so that we focus maybe a little bit more on our stronger areas like interoperability and sort of running the same types of code in different settings, where a standard is a key part of making things work, and maybe less on sort of the things that don't require interoperate, perhaps.
Thank you. Now that we drained the queue, it'll be good if you can actually take a look at the charter. I just posted the link to the draft charter onto the chat link. And if Lorenzo brings it up and shares, we can probably look along on your computer, because I think it's like very small font for people in the back to look at it. And
it was written by someone with an 80-column screen.
Yeah. Come on,
oh,
yeah.
I can reduce the number of lines on the screen, yes. I can also copy paste it into something that doesn't have that restriction. Yeah, let's try that. Let's try that. Ah, no, I can't. Okay, fine.
So the idea is not to like discuss the whole thing here, but take like a high level look at the charter and see if there's something missing or there's something we shouldn't be doing, and kind of take inputs on that. Like, of course, the working group is not going to get chartered right away, even if everybody loves it. So like, just take your time to do this. But if something immediately jumps out at you as like being off, or like, something missing, so just like come up and talk. But otherwise, like, review at your leisure. Thank you, Eric. Eric or AD?
Yeah, I was going to say one of the things that's not included in this charter is the must have 17 interoperable implementations before we advance kind of thing. But that's a good candidate for inclusion.
With different Indianness, you missed it. With different Indianness.
Indianness, yeah.
Middle Indian.
So one thing we might want to note here
does it have to be in the charter, or? Oh, sorry. Can you repeat?
Does it have to be in the charter and just be a rule created by the working group, right? What's the precedent in the IETF?
Mike?
Dave.
Does it have to be in the charter, or can it just be a social convention imposed by chairs? Yeah, I mean both are fine.
Yeah.
I mean, a charter is a kind of a mini governance doc. I think we can sort of decide on how we want to mini govern ourselves. But I'll defer to the chair.
I just wanted to say one thing that you'll note just by looking at what's on the screen is that the initial focus will be on sort of documenting the existing state first, and we can decide as part of chartering the group, whether we want to sort of continue, take stock, stop after that, and so on. So just and also, like, we would have to realize that first of all, any new activity would first require this to be standardized. So we kind of have to do this first, right? Just wanted to point that out.
Thank you.
Lars, I got two quick points. So one is you don't actually have to have this multiple interoperable implementations paragraph unless there's a sense that that would be helpful to add, right? And if it is, then somebody should make that suggestion and we can, hum on it or whatever. We haven't hummed yet. It's a weird
Not
boss.
yet. Like we're getting there.
If you want to, switching tracks, if you want a preview of my sort of 80 review, if this ever comes before the ISG, I would encourage you to, the bullet list is sort of longish. It might make sense to like break it down and say, these 3 or 4 things first. And once they're on track, we're going to do this other things. I would also encourage you to think maybe already a little bit of what things should be standards track versus is there anything informational or experimental here, and sort of just clarify that so that it's a bit clearer. But it's basically the usual homework you do when you like polish a charter. But I think for the first cut, I looked at this before, it looks pretty good.
Perfect. Thanks, Lars. I think the milestone stuff needs more work, but at least like the charter text is like kind of in a good shape. So thanks, Christoph, for like, and Alexi for like working on this closely with Dave to get this up and going. Thanks. So just give you a few minutes if you had a chance to look at it. If something stands out, like just come to the mic or like make a comment on chat. Anything sounds good. Eric?
So in terms of, Eric Nordmark, in terms of extensibility, so it has some text about it, but I wonder whether it's useful to sort of work on that document in parallel with documenting the current state of things, sort of figuring out, as a group goes through, here are the different things that we're standardizing, the existing state of things, also collect in a separate document saying, here's what we think are reasonable extensibility rules for this particular thing or that particular thing, right? So that we're collecting that in parallel, because otherwise you might get stuck a bit because the larger community might say, hey, we need this feature. Well, we haven't even started thinking about in IETF about what are the rules that are going to govern adding that feature. So some parallelism would be useful, I think.
I think Dave might answer more, but I certainly think part of the intent to do this in the first phase of the working group, if one gets formed, right? Like not to leave it till later. Yeah, go ahead, Dave.
Dave Taylor. Yes, that's what I was going to say is my opinion. In order to have an RFC, you got to have an INA consideration section. So either it says nothing or it says something, and so the working group has to decide whether it says nothing or it says something. So if you look at the instruction set, is the opcode space an INA maintained registry or not, right? That's a job for the working group to say, and the INA consideration would say it. And if it's an INA maintained registry, then you have to have the rules for it. And in order to figure that out, then you had to talk about what the extension process is. So it kind of drives that naturally by you saying either there's no considerations for IANA, right, which is saying there's no extension process initially, and you do that later, right? But we actually have to have that before you can go to RFC because the IETF requires you to have an IANA consideration section. So,
thanks, Dave. David? David, did you want to talk and change your mind? Okay, cool. Thanks. Not David Taylor, but Lamb Partner. Okay, so if there's no further questions, I think we are going to the questions, right? Like, so this is the fun part of the BOF, like everybody loves this. And yeah, so I think like most of you who have been in the IETF, you kind of understand like why we are doing this, right? So the goal of the BOF is to demonstrate like some kind of community support for doing this work here, right? So there's a problem that needs solving, we understand it, and a bunch of people are willing to work on it. And that's kind of what we're going to go towards and ask you a series of questions. So the idea would be personally to convince our responsible AD, who's Eric Klein, that there's interest in taking this work forward, right? Like, and that's kind of what we're going to drive towards. So with no further ado, let's go to the pre-questions, which is the next slide. Okay, so I'm kind of going to go with a series of hums for each of these things, and like hum, like, and if you're remote, you can either type or I don't think we have the tool anymore, do we?
There's a raise hand tool, right?
Yeah, so I think we can like not. I don't think the humming tool exists, but people can raise hands, right? Yeah. So yeah. So I think like the idea would be like we ask a question and hum if you're in the room, and if you're remote, please raise your hand if you want to say yes to that question. And I think we'll certainly ask like for people who do not agree. Oh, you want to use the show of hands tool?
Up to you. I mean, if the remote folks want to.
Okay, cool. Thanks. Okay, so the first question is, is the problem statement clear? So as described in the draft charter. So the question is whether it's clear, and I'm going to ask for a hum for the people in the room. If you think it's clear, please hum. Lorenzo, are you going to run a remote poll?
Yep.
Okay.
Oh.
Correct.
Is
So if you're not in the room, please participate in the remote poll. If you're in the room and you want to cheat, please go ahead. It doesn't make a big difference.
I think both local and remote seem to agree that it's clear.
Okay, thank you. So I want to ask the negative question as well. It's always like good to have. So because I did see some people did not raise a hand. So if anybody in the room or remote thinks that the problem statement is not clear, please get in the mic line and express your opinions. Thank you.
That's what you said, right?
Yeah. I think it's easier to kind of like ask for people to come up and say something, right? If they don't think it's clear. Okay, so we have 3 people, at least remotely, who have concerns about the clarity of that thing. So I would love to hear from you. And you're certainly welcome to work on the mailing list to do it too, but it'll be great if like people in the room get to hear your opinions too. Okay, not seeing anything. I think this is like something we need to investigate, Lorenzo, at some point, right? Like to kind of like find out like why people thought it's unclear, but we can do this on the list after. So does the community think the problem statement is well scoped? So like, do people think it's like of a scope that we can actually complete in a reasonable amount of time? So the question is whether it's well scoped. So if you think the problem statement is well scoped, please hum. If you think it's not well scoped, please hum. And I think both of them can go on the same poll. So if people didn't raise a hand, so
we have 2 who say it's not well scoped. So that's again something to take to the list.
Yeah. So for the people who think it's not well scoped, did you want to speak up at the mic? Is it because you think the scope is too large, too small? Love to hear from you either now or on the mailing list. Thirty more seconds.
We have a few more actually.
Yeah. Okay, I think we can close. Yeah. So there are certainly people who think the scope has to be more well defined, like either tighter or looser, but they don't speak up. So it's kind of hard for us to figure out what needs to change. It's certainly something we will like look on the mailing list after. So does anybody believe the problem is not solvable? So if you think the problem is not solvable, please hum. Okay, I did hear somebody in the room. So is that Antoine?
Yes.
Would you like to say something? Did you want to talk to the mic?
I think maybe it's related to his earlier
Yeah,
concern.
it was related to my previous question, so I'm consistent with what I told earlier.
Perfect. Thank you. Merci. Thanks. And
I wonder if that means that Joel has changed his mind.
Don't know. Let's see. So does anybody believe this is not a useful problem to solve if you can solve it? So Antoine, you can vote whichever way you want and still be consistent. So if you think this is not a useful problem to solve, please hum. Okay, nobody in the room.
Do we want to hear positive support as well for this question? No?
Okay, so I think like it's fairly clear that like people believe it's useful to solve. So we'll just go to the questions because these are not the real questions. It's kind of like setting the baseline for the questions to go forward. Okay, so now for the real BOF question. So Eric like is watching with like very keen intent. So the first question is, who's willing to author, contribute, or edit documents in this working group? So raise your hand because I kind of need to see like the amount of support, so the hum is not good enough. So who's willing to author, contribute, or edit documents in this working group if it is formed? I'd say about like 12, 15, doesn't matter. The number doesn't matter. So thank you. Remotely.
Oh, sorry.
No worries.
Oh, show of hands? You want?
Yeah.
We have a couple of participants.
I think it's good. Thank you. Thank you. So Eric, like, so just as an observation, there's like a reasonably sized community. It's not huge, but there's like a significant number of people who are willing to do that, just so you know. Yeah. So second question, who in this community is willing to review documents that get produced here if there's a working group? So raise your hand if you think you're willing to review documents at some point during this life cycle of a working group. Sure.
Yeah.
Hopefully you read other people's documents
you
as
can
well.
write and review.
Yeah. That's really significant. And if you can do the remote poll as well.
Yep. 12 raise their hand. 13. 14.
So Eric, significantly large part of the community is willing to do that. And this question is kind of like a little bit weird for this BOF because we kind of know there's no other working group in the IETF to do this, but I'll still ask that question. So it really doesn't matter. So I can skip through this unless like Eric and Lars insist me ask the question.
You should go to Interior.
No, not Interior. Okay, so I think I'll just skip to the next question. Is there support to form a working group with the proposed charter? So this is again assuming that we'll iterate on the charter. And another thing, which is not a general BOF question, but it's relevant to us, that all the licensing and legal stuff gets resolved. Okay, so there's not, Lars is not going to like let this happen without the legal stuff getting through. And Eric is not going to obviously do this without a charter that agrees with the stuff. So I think given those provisos, like assuming that the legal stuff is worked out and the charter comes to a acceptable thing with all the people who contributed, how many people here support forming a working group in the IETF? So you can hum if you support forming a working group. I would see it as a very strong support of the room. Yeah, I'm going to go through like support for forming it. So is there anybody here who doesn't support forming a working group? Please hum. And Joel, go ahead.
I said it before, Joel Halpern from Ericsson, but given that you've asked it explicitly and said, please speak up. The work looks really interesting, and I can see why you want to standardize it. It does not, as far as I can tell, fit with the IETF. The fact that somebody wants to use this for a control within a router control plane and affecting the router data plane is great. I don't object to that. We've had people do APIs to routers. Some of them even tried to standardize them, but not here because it doesn't really work well here. It doesn't fit. I know people disagree with me, but I wanted in fairness to make the statement.
No, Joel, that's fine. Like I really want to hear that thing, right? Like, and Lorenzo has something, but I do have an answer for you too, if you can stick around. Thank you.
Yeah, I don't want to disagree. I'm just wondering how you are. Seems like you're skeptical that we'll actually be able to do something right here, which it's good to be skeptical for anything that new that we. I'm wondering how you would feel about attempting to do something that's like slightly more well defined, like for example, like more conservative milestones that are primarily around like standardizing existing work, and then taking stock and seeing, okay, like, you know, how did that go? Just out of curiosity, really.
That is an interesting perspective. If we focused on only the short term, and we've done a number of working groups where we've said, do step one, demonstrate step one works, then we'll consider step two. While I don't know that I would be comfortable, I would be much less uncomfortable, I can say, with that. I mean, I'm trying to make allowances for the different things. I do have to admit that part of my problem is a much subtler problem, which has nothing to do with this work. And that's why I keep talking about whether it fits. It's the effect on the IETF as a whole of, well, there's an interested community and they're good and they're willing to work with our rules, so we should let them in. Well, on one level, I like that. And on another level, it makes me really nervous because there is an immense amount of work out there. And the IETF cannot do all the work. It doesn't work. No matter how much I like the IETF, I don't want it to be attempting to be the answer for everybody, even the answer for everybody related to networking. We don't standardize Kubernetes and we shouldn't be. They do their thing, and whether I like it or not is not even relevant. So that's where I'm coming from.
Thank you, Joel. And like certainly we'll work offline with you to kind of see if you can step this through in the right way. So thank you very much. And Lars, would you like to make a comment on the same thing?
I just want to argue against Joel again. Sorry, Joel. So, I mean, this is not about all the things, right? This is about one very specific thing where, unlike Kubernetes, where, you know, a foundation exists and an established process, for this, it doesn't. And this community is actually looking for one, and we have one. And it's also technology that is, you know, more than adjacent to what we're good at, right? There is overlap. We found out that, you know, long-time IETF participants are very active there. And when we did the side meeting, we found more people that were at the IETF that did something with eBPF that we didn't know about, that they showed up because, like, I saw this thing and I'm here, I have been here. So I think, yes, this is not something that would slot into routing or it would slot into transport very neatly, which is why it's an int, right? Which has a little bit of a fuzzier scope. And I would argue that's a feature that the IETF is sort of a bit malleable, that we don't have these fixed boundaries. But I mean, we can't keep saying no to work that is, you know, this new, and maybe, you know, that's not the IETF way, right? We can't just say like this is our 6 areas and never shall we do anything new. That's not a recipe for success going forward. I really disagree. I think we should do more new work that is like this.
The mic line is cut off. I don't know if you're in the room or not, but yeah. No, I just want to close the mic line. Media got past it. Charles didn't, unfortunately. Sorry, Charles. No, I said Charles didn't, unfortunately.
Mia Kulin, I just wanted to jump on something that Joel just said. You said we cannot let more people in. I think this is really not a good way to see it.
That's what I said. At all.
This is like let people in. That's exactly what you said. But anyway, so I think in this case, it's also not about like another community just imposing a problem on us and we should solve it for them, right? That's not. It's a community who's willing to do work in the IETF, and there's like a huge overlap between these communities. So I see this as extending our community, if at all. And if that what works out, I would be really excited to see this extension. Personally think this is a good problem to solve here. Yeah, I'm picking a little bit, but like having a view about letting somebody in or not or whatever is not how we should see it, I think.
Yeah. So I mean, one point that Joel made, or that we had in the conversation, that I think is actually really good an important one, and that was he'd feel a lot less uncomfortable, maybe still not entirely happy, if we structured our milestones in the charter in a way that the first step is really produce the documents that document the existing behavior, make sure they interoperate. And I think that's a very good argument. Before we go off and do crazy things, we really need to show that we can produce these documents that document the baseline, that sort out the existing interoperability issues, get those done. And I think extensibility is actually part of it, but don't really start anything new before we finish that. And I think it's probably a very good idea to make that very clear in the charter and the milestones.
Oh, thank you very much, Christoph. Eric, you get the last word. So from the chat's point of view, there's like significant support to form a working group, charter to be decided, specifically to face the deliverables. Like that's kind of the exec summary for you.
Yes, thank you very much. So I think my only last word would be to say thank you to the chairs for organizing this. Thank you to all of our speakers for coming, especially those who are new to the IETF. And thank you to all who considered and gave us your time and your opinions. Thank you very much. Oh, sorry, go ahead, David. Why don't you go? David, there's a side meeting.
I'm Eric Klein, right? The last word is there is a side meeting to talk about follow-ups from the BOF action items and stuff. Anybody's welcome to come. Thursday, 5:30 p.m., G301.
Thank you very much. Lars, did you want to say anything or are we close? So thank you very much all for coming. Like we loved your comments. So, and please keep engaged on the mailing list and love to hear more from you. Thank you. Have a nice day. There's like a fantastic barista for like awesome coffee. Please go ahead. Thank you.
Thanks, folks.